Hello and welcome to the latest episode of the Energy Insiders podcast. My name is Giles Parkinson. I'm the editor-in-chief of Renew Economy and editor of the EV-focused sister site, The Driven. And joining me, as usual, is ITK principal David Leach. David, I trust you are well in that striped shirt of yours.
Yes. Well, I thought I'd put a striped shirt on in honour of our guests, some of whom may be silly enough to watch the video rather than just listen to the amusing words. But anyway, we've got a great guest who actually this week, unfortunately, I couldn't attend, Giles, but I've read the transcript and he had some great things to say.
Look, it's very true. Look, we did catch up with Dino Otranto, the CEO of Fortescue Metals. I should say we. I said I because you were absent and I had to hold the fort by myself, which is a shame because I think I needed your help at various times. But look, it was an interesting interview. It was conducted before we discovered that there were some more job losses at Fortescue Zero, which is interesting because it's basically about sort of switching manufacturing capabilities from Australia and in England in particular to China. But Fortescue is surging on with its real zero targets for the Pilbara in 2030. Hasn't been so successful with its grand hydrogen plans of a few years ago, but Dino Otranto has some interesting things to say about that. But anyway, without further ado, let's hear from Dino Otranto, and then we'll get back to talk about the news of the week, which includes the Queensland Renewable Energy Plan and what Origin is up to with Eraring. Here's Dino Otranto.
Pleasure to be here, Giles. Thanks for the invite.
Well, look, lots to talk about with Fortescue, but I really wanted to focus on your real zero targets by 2030 because they're so out of line, if that's the word, with what everybody else is doing. The federal government's got an 82% renewable energy target by 2030, and people are wondering if they can make that. You've got a real zero target by 2030 for the Pilbara mines, which is no small feat. They're pretty major businesses. Are you still confident that you can get there? You've had some successes, obviously, but as always in these things, some setbacks along the way.
Yeah, thanks, Giles. So there's a lot in that question. The answer is fundamentally yes. We embarked on a program a few years ago now, an 8-year program. We started with net zero and we changed our tax. We can talk a bit about net versus real, if you like. Now it's real zero for our terrestrial operations here. So we emit between 2 to 3 million tons a year of CO2 from our operations, largely through the consumption of energy through electricity and the generation of electricity, and then the consumption of that energy through mining trucks and heavy machinery, conveyor belts, rail, etc. And so the plan we have is to convert all of our generation, all of the distribution, and all of the consumption of our energy mix. And happy to report we are, doing pretty well against our journey. We've still got 4 years left, and just under 5 years actually. And technology is changing so rapidly that almost month by month we're gaining confidence. And we've just recently announced a series of really exciting partnerships, which broadens a very rich tapestry of partners we have, and it's giving us more and more confidence to make sure that we will be real zero, but more importantly, it's profitable. To demonstrate to the world that this is about economics, not just climate change.
We'll get to some of those technologies and some of those partnerships soon, but probably an opportunity for you to explain why you went real zero and what that means rather than net zero. I guess net zero includes offsets. Real zeros is basically a commitment not to be burning any diesel or gas for your operations in the Pilbara.
That's correct. So we have a view that the offset market is largely opaque. And fundamentally, the purchase of offtakes doesn't really change your own emissions profile. You're kind of incentivizing others. For us, we do have a plan to be completely real zero, which means that we will offset, avoid all of our consumption of hydrocarbons in our portfolio.
That seems extraordinary because you must go through millions of litres of diesel a year for your giant trucks, for your other mining equipment, for the trains and everything else. It's perhaps it's time to work down through and just touching base back on the it's for economic reasons rather than just environmental reasons, or as much about economics, because it's interesting when you hear analysts, and I've often listened to your analyst briefings on quarterly reports and things like that. Are they fully on board? Because analysts kind of care about the short term, they care about dividends, they want to assess your ability to pay dividends. They seem to understand, oh, here's a big miner that needs to invest a lot of money into building a mine, not going to be any revenue for a while, but then there'll be a lot of revenue. Do they still have that same sort of patience when they're assessing transitions like this of existing operations?
Yeah, look, analysts, depending on buy side, sell side, particularly the conservative nature, in my view, of mining analysts in general, over the last couple of decades, there's been some notable misinvestments by big mining houses. So, look, I would suggest that they're a very skeptical bunch, very smart, intuitive. I mean, they have a lot of pressures around retirement funds and pensions and short-term profit takers, for instance. So that they are, rightly skeptical in what they're doing, and what we're doing is taking some risk. But I think as time is going on and you're seeing real things, I think that's the really important factor for us. Is we do talk a lot about our aspirations, but we balance that with the demonstration of real tangible differences. Like, you can see solar panels now. You can see upwards of 600 kilometers of high voltage, 220 kV GIS network that's being installed. You can see trucks. You can see mining excavators. You can see battery storage solutions being installed now. So this isn't something we're going to do. We're doing it now. So once the investment community understands, the announcements around solar and battery and economics of deploying electricity in the Pilbara, for instance, which is very different to a city that you and I may live in around Australia, very quickly you'll start seeing that, hey, this actually makes sense. And then you couple that with this abundance of sun and wind we have in the Pilbara. We're very uniquely positioned, where we have nearly 3,000 hours of sun. All right. So it's an enviable position. And when you describe those fundamentals to the equipment suppliers of solar, wind, and battery, they quickly realize, hey, this is going to be economic. And we're making it economic at 1,200 hours in Beijing in China. Then it's largely a no-brainer, really, to do it in the Pilbara. So day by day, we call it our risk profile is changing, and we're becoming a lot more certain about real zero, but then the profitability margins.
Yeah. The transition, in fact, in the Pilbara is just quite extraordinary, because the Pilbara is one of the biggest economic zones in Australia, yet it's probably the most polluting in terms of sort of emissions and its share of fossil fuels, like about 99%, I think, in its grid. And basically, until recently, all its mining equipment was sort of diesel based and what have you. And you're making this transition in just a few years to go to real zero. That's I guess it's pretty exciting to watch. Let's have a look at some of those technologies. Most recently, you just announced the purchase of Nabra Wind from Spain. This is this kind of like self-lifting turbine technology. You're planning the first of your big wind energy parks. You've got something there called the East Pilbara Generation Hub. I think it's 2 gigawatts. You're talking about the first stage of that. You've signed a really interesting contract with Evergen, which is a Chinese manufacturer new to Australia. So presumably they might have given you a good deal. Plus, you've got this new technology for this self-lifting turbines. Tell me, why did you buy Nabra Wind? Because it doesn't seem to have been sort of deployed at scale much anywhere. And what makes you so sure this is right for what you need?
Well, thank you, Giles, firstly, for being so well informed about what we're doing. So we've been working with Nabra for some time, and as all commercial enterprises, we're always looking for opportunities for value. And we felt the partnership with Nabra fitted our values. It was in an area where it solved one of the key constraints about mass deployment of wind in places remote like the Pilbara, which is largely the logistics of getting blades and towers to where you want them to be built. And when you think about what Nabra is, the concept is very similar to erecting tower cranes, right? And when you look at a tower crane being erected in the city, for instance, they can erect them right in the middle of a street and have hundreds of meters access by itself constructing itself. And it's constructed by parts rather than in one large structure, which means then you can import them, offload them in very remote ports, which don't need the large unloading facilities that you do need for a large conventional tower crane. So we thought we were partnering with them, and an opportunity came up. And as you've rightly pointed out, we've concluded the acquisition, and we see that application for that tower crane actually serves a market far beyond just Fortescue, predominantly, as I said, in locations which have the logistics struggles.
Yeah. And so the first of those turbines, I think, are being built in China at the moment. I think there's a pilot one, and then you're going to be rolling out, I think, maybe 17 or 18, I can't quite remember now, in the first stage of this project in the Pilbara. I think from next year, maybe. Is it going to happen that quickly?
That's right. It's in motion. And the reason why it's being erected in China right now is because you actually have to have the tower and the turbine certified in unison, which makes the assembly safe. So you need to have a test facility, largely being supported by a partnership with Envision. It's an Envision turbine that will sit on top of now Fortescue Nabra structure. And once we can meet the testing and accreditation requirements, as you said, we'll look for deployment along our decarbonisation timeline for 2030.
And the other thing I think it benefits from is just less concrete in the foundations. And concrete, apparently, in hot areas like the Pilbara, just a pain in the ass to actually sort of do and to install. Temperature sort of controls and things like that, sort of water needed, and goodness knows what else. So I guess that's a benefit as well.
It is a clear upside in what we're doing, and you can imagine there's a large concrete structure underneath each one of these towers to deal with the structural loads that you have. You do these through piles. You do use some concrete, but it avoids the need to build a large concrete plant, for instance, which you do in many of these mass wind applications. So yeah, a lot easier and a lot less cost in terms of the civil works.
Okay. And what about the rest of your plan then for bulk electricity supply? You guys, I think, have just completed, you had Chichester, which was built by Leinster a few years ago, which I think does the Cloudbreak line. You've got your North Star solar farm, which is under operations. And you're building another one. I can't bloody well remember it now. Is it Cloudbreak or is it Christmas Creek, maybe? I'm guessing.
Wow. And it's impressive, your knowledge. So we have a number of underway, 190 megawatt. We have a soon to be started 644 megawatt facility, and that'll take up to between 2 or 3 gigawatts of combined wind and solar in the region. And we haven't picked one particular site because the weather modeling that we've done and the disparate nature of our mines, rail, port infrastructure means that we could decentralize the installation and actually reduce the risk and maximize the sun and the wind in that balance. And we spent a couple of years. Yeah, typically you peg an ore body and you start drilling and exploring, understanding and defining your ore body. We did a similar thing with sun and wind, where we erected a lot of data towers to collect information of the last few years, and we have a really good understanding of where to deploy our technology to make sure we gain the most energy when it's available, which largely then reduces your capital footprint in more solar, wind towers and battery storage. The other advantage that the Nabra towers give us is the ability to go higher. So you can put a bigger wind turbine, and actually we found that wind is not all the same. So as you go up in elevation, it's actually different. So you can find airstreams that have a higher potential wind or a lower potential wind than you ever thought. So you can actually then map out. It becomes a 3D map and landscape that we've now constructed over a distance which is some thousands of kilometers in the Pilbara.
Right. And so there you can have a couple of gigawatts of wind and solar then. That will then account for your entire electricity requirements at the sites?
That's correct. Yep. So, and we're electrifying. So, it's as you said before, we use roughly up to 900 million litres equivalent of diesel, right? If you converted all of the electricity generation and the diesel consumption into diesel, just to give people's orders of magnitude of what
That's a lot of jerry cans.
it is, and it is a lot of trucks of diesel driving to each of our sites to fill up the trucks, but also run some of the generators that we have. So we've literally built an extension cable network from Port Hedland through to all of our mines, and now we're plugging in the solar and wind farms. And as we're doing that, we're progressively lowering the carbon intensity of our operations. And we're finding that as months and really months go on, because the technology is changing that quickly, the economics improve almost day by day. And each contract we sign, well, with each sequential solar, wind, battery installation that we have.
That's interesting. So, okay. So that large-scale technologies, they're the ones coming down, wind, solar, batteries.
Yeah, so we look at really 3 key technologies to enable economic decarbonisation for the iron ore business. One we've mentioned is solar. That's largely come down in terms of the panel cost. We're doing some exciting work on installation costs, because that's the next level of cost out for solar generation, particularly in Western jurisdictions where the cost of labour is somewhat higher. We're looking at autonomous and robotics to install solar panels, which is then taking that cost profile to the next level. The Nabra partnership and some further cost out on the turbine in terms of its size gets the cost of the wind down. And excitingly for us now is the cost of battery storage. We've seen come down drastically over the last couple of years. And as the cost is coming down, intensities are going up. So you're getting more energy out of the battery, similar to when we had the old D-cell battery in the torch, and it was replaced by the lithium battery, and now a little USB cord. And the size of that battery pack is, remember the old dolphin torches that you have?
Yeah.
Now you can get more lumens out of something that's that big. It's actually following the same type of path.
Okay, let's talk about then some of the equipment that you're using at the mines. One of the main ones is the haul trucks. I mean, these are massive machines, 240 tons. Last year, I think it was last year, now you signed a $4 billion agreement with Liebherr for a whole bunch of several hundred of these trucks. I can't remember, maybe it was 400 trucks, but also other mining equipment. How are you going with that? You've had a I think is it Roadrunner that you've had on site there as the test one, or is that the hydrogen one? I can't remember now. How are you going with that technology? And maybe you can also explain why you actually did a partnership with XCMG, I think it is. They're now going to build almost half of those trucks. I'm just wondering why that happened.
Yeah, look, maybe I'll tell a bit of a story of the history of this. Well, we put the call out to our suppliers around partnering with us on net zero at that stage, and then real zero now. And what that meant was having a commercially available zero emission truck. And at that point, and it wasn't too long ago, actually, it seemed pretty crazy. Lo and behold, not many people put their hand up to say, hey, you can buy one of these off the shelf. And that worried us a little bit, because we knew what the next challenge would be was, we'll go and build one yourself, which was a pretty visionary statement from our chairman. And look, less than 100 days later, we had built one. I mean, it didn't go very fast. It didn't go very far, but hey, we actually did it. And what was surprising from that moment on, because it was a bit of a Frankenstein, we put our own power system into a readily available chassis. It was a Terex chassis, which is a very long-standing brand. It was a Terex 4400 for those out there who like their old trucks, mining trucks. So we put our power system inside this, and it ran quite successfully. Well, in our view, for something to pull together within 100 days. And then you had Liebherr step up. And Liebherr said, listen, we're really impressed with what you can do, right? And maybe the partnership is with a mining company, not a traditional OEM.
Mm-hmm.
Because what we found is often disruption comes from places that you'd never expect. And we have a saying in our organization is, if you want real change, sometimes the analogy is, if you want to learn to swim and jump in the water and burn your boat, you learn pretty quickly to swim or not, right? And that's kind of what drives us, is we find that the creativity and entrepreneurship of our workforce help solve some of these problems. And that's what we saw with our first truck, the Roadrunner truck that you mentioned. And then that led into the development of two types of trucks with Liebherr. One was a hydrogen fuel cell truck, and the other one was a battery electric truck. Now, there's sometimes myths about hydrogen versus fully electric trucks. They're largely all an electric platform.
Yep.
Okay, and then the auxiliary, which drives the electric motor and the battery packs that we've built, can come from a hydrogen fuel cell, it can come from a combustion engine, or it can come from further batteries in a fully battery electric truck. So the architecture and the foundation is largely the same. And then we tested out at the time a hydrogen fuel cell and a battery electric, one being plugging into a grid and one being for a potential hydrogen fuel source that we can touch on if you want while we're not there at the moment. But for us, economically, at the time, it made sense to go fully battery electric. So that led then to the acquisition of Williams Advanced Engineering, which was largely a power system company that was a spin-off of Sir Frank Williams Formula One racing days. So we inherited a pedigree of research and development and tech development of really racing power systems. And the synergies between the racing industry and mining was not as far-fetched as people thought. We're all trying to move a lot of stuff really quickly. Power to weight was the secret, and in fact, although we're at opposite ends of the planet, the synergies and coming together of how technology was developed was pretty special in only a few years ago. So that then led to the partnership with Liebherr, and Liebherr suggested, well, we'll supply the chassis, Fortescue, you come and do the power systems with us. And that then led to a deal to purchase not only trucks, but also excavators and a bunch of other equipment with Liebherr. And at the time, we were the only horse in the race. Okay, it was a Fortescue Liebherr partnership. And as I said before, technology has changed, and it does pretty quickly. XCMG has come a long way in very short times, and that's led us to hedge our bets in terms of the truck fleet. And it's always a good decision not to have all of your trucks in one supplier. That's typically what mining organizations do. We have two suppliers. So that's where we are now. We'll have a 50% fleet of Liebherr, Fortescue trucks, and then a 50% XCMG 240-ton battery electric truck.
Okay, and these will start rolling out at scale when you've got a couple on site, I think. But when will we see them?
Next year will be the big year, and then, like you said, it's north of 300 trucks. So that'll take a couple of years to fully roll out. The good thing is, on the Liebherr side, we've already got a fleet of Liebherr diesel electric trucks. So we're getting very familiar with the electric power system, the new types of trucks. So we've given ourselves a couple of years in advance to understand how to operate these things. And what's really great is, although we've introduced a whole new technology already, although it's diesel, but diesel electric, we're still maintaining our lowest cost unit position in the iron ore market. So although analysts, to your question before, would say what we're doing is at risk, I mean, I just had to say, look at the results that we're getting. We've already introduced electric excavators. We've already got diesel electric trucks now on board. We've got solar systems. We've got a reticulation network that we're managing as well. And we're still maintaining, if not improving, our cost position every single year and meeting record production.
Some of the technologies that go with these big trucks, I mean, you've got really big batteries. I can't remember how big they are now. Is it 15, 18 megawatt hours or something like that in each truck? Then you've got your fast charging equipment that you're actually also developing with the old Williams acquisition, now part of Fortescue Zero. Can you tell us anything a bit more about that?
Yeah, so we've learnt quite a bit around a lot of skepticism about what we were doing came about. Well, you need to have the same life as a diesel fuel tank in your battery systems. Well, I'm not sure if you've got a mobile phone, Giles. Do you ever run it all the way to zero and then fill it all the way up? Or what do you actually do, right?
I'm not as organized as I should be, but mostly I just sort of top it up as I go.
I mean, that's largely, I think, how we all have generally now use our mobile phone. And those of us who have electric vehicles, or have a little Mini Cooper electric, I'll just top it up at night, right? And as we're deploying in the mines, where we have a reticulation system of high-speed chargers, which actually are autonomous. So they will automatically come out where the truck is in an idle position and fast charge and top up that vehicle. The whole thing is managed by a very sophisticated operating system. So think about that. You're deploying sun, wind, through the battery system, through your reticulation, into the truck. You've got insurgent high voltages when you plug it in. It's a very, very sophisticated power utility business that we've largely had to build out of necessity. And some of our aspirations around energy projects to solve the economics of providing green electrons or electrons at cost to mums and dads around the world, you need sophisticated utility style networks. And we've built that over the last couple of years. And we now have commercial products that we can sell in this space. And we are already selling some of our application stack in this market.
And some of the excavators that you've been operating for a while, they've already done some considerable fuel savings. Can you just tell us briefly about that?
Yeah, so we deploy a fleet of Liebherr 9400E electric excavators, and they are tethered. So that means that you plug them in. For iron ore open pit miners, that was a little bit scary, but I remind them that tethered electric equipment has been used for a long, long time in mining, underground mining. The coal industry in Queensland, for instance, used this. So this is not new technology. It's new technology for iron ore miners. And again, I point to the underground mining environment. Electrification of underground has been around for about 50 to 60 years because you can't put humans in the line of diesel particulate emissions. It's toxic. So we've already solved that. So to say that the technology doesn't exist to make a slightly bigger truck, I just don't think that people were trying hard enough. And that's been our experience.
Yeah. And some of the developments you've been, the Williams racing team, I don't know whether they're still called that. They've been, what was the word called? The sort of the pit boost technology that you've just been rolling out as well. Sort of charging cars. And you talked about Formula One. Presumably it's that same sort of technology that you're going to be using at the mines, and it's the same principle where you can just sort of charge a battery, maybe 100 kilowatts, 150 kilowatt hours in just a couple of minutes.
So I can hear the lawyers already in my ear. I'll just clarify that. We're not affiliated with Williams Racing Team. We have, and we're not Formula One. We're called Formula E, and we're the Fortescue Zero Formula E, which is a fully electric racing circuit. As you said, we've developed what's called a pit booster, which is a large, a high-speed, quick dump of electrons. And the way I describe it to people, remember the old days in the 1960s of Formula One racing, you had a big jerry can and they just open a big valve and it would all dump into the car, close it, and away they go. Very similar approach. You have a large battery-style capacitor that you completely discharge instantaneously into a receiving battery vessel, and away you go.
Amazing. Let's move on to trains. I don't know whether that's still part of your Real Zero ambition. You had talked about this infinity train for a while, which is just, having the principle of that was just using gravity to basically have a train going downhill, recharging, regenerating, and then filling its batteries enough to take the empty train back up the hill to the mine and so forth in the big virtuous circle. That doesn't seem, if the reports are right, to have worked out quite as planned. What's the latest there? Is that still part of Real Zero? And what's the alternative if the infinity train isn't the answer?
So yes, absolutely is part of our plan. Our ambition is Real Zero all terrestrial operations, which includes the trains. We were investigating two types of technology. One is using ammonia in a combustion two-stroke engine, which we see applications with shipping and rail, and also using a fully battery electric locomotive, which is largely available already. You can the the train here in Perth or the trams in Melbourne are a catenary electric train that get driven by overhead poles and wires. So the concept of the motors and all of the traction motors that you have is already available. The challenge with what we have is it's 40,000 tons per train, 2 kilometers long, traveling hundreds and hundreds and hundreds of kilometers. So even though the relative level difference was quite significant from the mine to the port, the undulations and the hills in the way, we're not quite there yet. The amount of storage you can get onto your battery to get over all the way, right? However, if you look at some of the releases that BYD has made, for instance, in the last few months, and even CATL out in the market, energy densities are almost doubling and tripling every year. So we are very confident that battery energy density will get to a point very soon that we can incorporate that into the train design, which we've already got. Hence the quite important partnerships now that we have with BYD, which gives us, in some respect, you're at the front of the line with this latest technology that's coming out. And you can also work now with BYD to design bespoke battery systems that can be used for your particular application set.
So the infinity train concept then is still alive. You're just hoping for a more powerful or more denser battery to be able to get you over those humps.
Yeah, look, it's exactly right. And again, I keep using the drill analogy at home, right? I remember when you first got your 12-volt cordless drill, whatever brand affiliation you have, it was pretty weak the first few years, and you still had your corded drill for the tougher applications. Now I think rarely people use a corded drill. I know I've got a flex volt, 24 volt something or other that can do all of what my corded drill used to be able to do, and that is only because DC brushless motors and batteries in those combinations can give now the torque curves and the battery distance that were required. That is exactly the same thing that's happening now with batteries and large-scale industrial batteries. And great for us, we're right at the forefront of that development.
So when do you think that BYD is going to be able to deliver you a battery that gets you over those humps, as it were?
I don't think it's that far away. I think definitely in the next few years. The announcements of high-speed charging in light vehicles, for instance, and 1,000-kilometer range batteries. Sodium ion is just around the corner. There's been some really exciting announcements about sodium ion lately, which help also around the battery life. That's the other part in this, is how many times you can charge it and the cost profile of the batteries. So I don't think it's that far away anymore, to be honest.
You mentioned trialing ammonia for the trains. How did that go? And tell us about your other ammonia applications. I mean, I'm thinking of the ship that that the company's been sailing around the world to key climate events and trying to get people to sort of change their port regulations to accommodate sort of ammonia bunkering. I think it is, if that's right. So, and this starts to lead into the sort of the hydrogen part of the equation, I guess.
Yeah, so where should we start with that one? I mean, let's just talk a bit of the chemistry and combustion of ammonia. It works very similar to bunker fuel. The only real difference in your combustion chamber in your engine, where the pistons kind of explode that fuel source, is the way that you volatilize or you inject your fuel. So you've got to work on a new injector manifold. We built our own 2-stroke engine prototype system here in Hazelmere in Perth near the airport. And we then developed that inverter technology, which then led to us adapting a large locomotive 2-stroke engine with a new injector chassis. And we built the associated ammonia injection tank and system, a kind of fuel injection system that you're familiar with your car. We put all that into a locomotive, and we were very successful in the technology of 2-stroke ammonia-based combustion, which for us has applications in locomotives and a mass market of locomotives around the world, mind you, over 50,000 locomotives that use this type of technology. and also ship it. So once we were able to do it on a small engine for a loco, we then procured I think it was a 60-meter vessel, and we retrofitted 2 of the engines to run on ammonia through that same injector technology. And now we are, as you said, sailing the green pioneer around the world, demonstrating that the technology is there. Now, again, ammonia is a derivative of hydrogen. And I'll get maybe into the details of where we see hydrogen. How do you make hydrogen is a derivative of green electrons. How do you make green electrons is a derivative of battery storage, solar, and wind. So it's all linked. And for us now, we've learned that the way to unlock hydrogen and its derivatives, so liquid ammonia, as we just discussed, or fertilizers, or explosives, all comes back to the quest to get a commercial green electron. Hence why so much of our effort is about deployment of solar, wind, and battery storage to create what everyone's seen as nirvana, which is 24/7 firming, cheap green electricity. And that can be used directly as electrons, or then what we're really excited about is creating that downstream industry of ammonia derivatives, or hydrogen derivatives, particularly for places like the Pilbara. We sail our ships to Singapore and China, fill them up with fuel, and sail them back down to Australia. Why not fill them up here, load them here, and create a bunkering opportunity here for Australia? I mean, we have all of the sun, we have all the wind, we've got technology now in batteries and solar panels and wind turbines and Nabra towers, all now at the precipice of coming together to then deploy that into a really exciting new industry. And we're looking forward to the International Maritime Organization's vote this week, which will then include ammonia for the first time as a bunkering fuel source for the global shipping industry.
And the conversion technology, so you've got the cheap wind and solar and what have you being produced in the Pilbara, the actual conversion to make the hydrogen and the ammonia, isn't that the big challenge though? Can you get the costs down on that?
Yeah, so to make the a hydrogen, you need the electron and water, and then you put it through an electrolyzer, as you say. And interestingly enough, and it's meant some tough decisions for us, but the cost profile of the electrolyzer stack is following the same trajectory as the solar panel, the battery, and the wind turbine. The electrolyzer stack, though, is at the very top end of the cost curve. So we're seeing already that come down, and we expect that to follow the same trajectory as everything else that's mass manufactured around the world. You start seeing the dilution of capital and the cost per unit come progressively down. And we believe we are close, probably a couple of years away, of getting those electrolyzer costs that low that you can combine them with the cheap electricity to make then the hydrogen and its derivatives.
And then that presumably might be a relaunch then for your sort of bigger hydrogen program, because a lot of that, your sort of global green hydrogen ambitions have been the ones that have been tempered over the last couple of years by various lack of demand, maybe the technology cost didn't come down as quickly as you might have thought, or the cost of new things. You've had to pull in some of those hydrogen projects.
That's correct. And we've been quite public about our, I would say, withdrawing of the projects. It's largely pacing the deployment of capital because, as we've just talked about, some of those cost projections have not yet materialized. And also, importantly, the market for the hydrogen molecule, whether it's in a solid or a liquid form, or the ammonia, has not materialized as we would have expected. Now, we had very ambitious growth projections for that. And even in our own backyard, we felt that because the cost of generating the electricity has come down so quickly, we can deploy the electricity into the truck versus the hydrogen into an energy form. What we're finding now is the hydrogen for us is probably most useful in the short term to generate green metal, which is a very ambitious plan we have in the Pilbara, which uses hydrogen in its chemical form, not its energy form. So you're using as a reductant to replace coal with iron ore to make a green metal here in Australia.
I was going to ask about that actually. Can you tell us a bit more about what you're doing and the scale of what you're doing up in the Pilbara with green iron?
So when you look at what we're doing for decarbonisation, for instance, we've already talked about the benefit of the sun and the wind that you have in the Pilbara. Well, it's right on top of a pretty fantastic ore body, okay? And along the lines of the reduction in capital profile of your solar, wind, battery storage, for instance, electrolyzers, if we can solve the reduction equipment cost challenge, which we're doing in the Pilbara right now, we can then mass manufacture these furnace units or reduction units with hydrogen and deploy them in the Pilbara. And what it does is then instantaneously solve what is one of the hardest to abate sector, which is the steel industry. At the moment, metallurgical coal is burnt in China predominantly with our iron ore, and it emits significant amounts of dust, pollutants, and also CO2. And China's declared it's not going to tolerate that anymore, and it is looking to transition its steel industry in our lifetime. As blast furnaces get retired, EAFs are being installed. They are looking for carbon-free sources of inputs, and green metal is one of those. And we intend to demonstrate we can do that in the Pilbara, in our own operations with our own lower grade fine iron ore, and demonstrate to the world it is possible. And I'm a firm believer that the technology will catch up and liberate the abundance of cheap iron ore that Australia has. And that puts us at a unique advantage over Brazil and Africa because of our proximity to China, our abundance of sun and wind resource, but also the abundance of low-cost iron ore we have in the Pilbara.
Yeah.
And I want to see that industry flourish for the next 50 years. But right now, the reality is we don't have a product that the steel mills want in the long term.
And it's actually quite future then quite critical then for the long-term future of your ore bodies to be able to develop that technology. So I'm guessing. And when do you expect to see the first results from this pilot plant? What are the timelines there?
We will finish building the plant this year, and then we'll get on to commissioning. So early in the next year, you'll see the first commercial quantities of green metal start to come out.
Okay. Just getting back to the overall picture, it's interesting seeing some of your other rival iron ore miners. Look, they've all got their own sort of races to run and things like that. I think they sort of just they've gone slow, or they've said they've got to go slow because the technology is not there. For electrification, for instance, they seem to be going slow in some instances on large scale wind and solar, possibly because they can't see the electrification. Yeah, I'm just wondering if you can comment about that and your rivals. I mean, maybe like all good sports people, you don't really worry about what your competitors do. You're focused on your own game, but and some of the pushback that Fortescue's been getting about this sort of pursuit of real zero, because it sounds very exciting to people in the industry, but it's often mocked by those outside it.
Yeah, I think look, we largely ignore the mockers and demonstrate through action and real delivery that this is possible. And I am 100% confident that as with any disruption to any industry, once you create a viable product, the market will flock to that product, and it can shift very, very quickly. If and when we produce an equivalent cost of diesel in our equipment in the first generation, why would you not change? There is, even if you're not a climate believer, it's just dumb business not to.
Should Fortescue reach real zero by 2030, and you're obviously very confident that you're going to be able to do that, what does that mean then for Fortescue? And what does that mean for Australia's general decarbonisation process and opportunities?
I mean, we've always said we want to be somewhat of a light on the hill for people to look to with real practical solutions to help decarbonisation of big industrial emitters. And what we'll create by 2030 at Fortescue is a complete orchestra of products, the software, the hardware, the distribution, the energy solutions, all of those solutions, which we believe is a commercial product in itself under the banner of Fortescue Zero. But more importantly, we'll have the only iron ore in the market with a zero carbon footprint.
That's going to be quite profound. I mean, it's good for Fortescue, both as just a miner and a supplier, but also as a technology provider.
Well, I think it spurs local industry, local manufacturing jobs, particularly if we go downstream into green metals. So I think it's a great thing for Australia, and we can demonstrate at a world stage that we're taking this seriously.
Yeah.
And I applaud the federal government for standing up. You know, the recent, as you said, the carbon reduction targets are very ambitious for the government, and it's very rare this day and age where everybody has an excuse to pull back, for real leadership to stand up. And I applaud Minister Bowen and Prime Minister Albanese for their international position on this. I mean, if I'm feeling a criticism for what we're doing, I can only imagine what Minister Bowen and Minister Albanese are going through.
Well, Dino Otranto, thank you very much for joining us on the Energy Insiders podcast. I sort of feel like we've just sort of done a big tour very quickly, but I really appreciate it, and good luck with the rest of the journey. And we look forward to hearing more updates about how you're going with those electric trucks, those big wind farms, the solar farms, batteries, ammonia
So
powered
how
ships.
about we go up into the Pilbara next time we meet, and we do this not in an office, we do it live on site, and you can go and see this stuff. It's real and it's happening.
That sounds like a brilliant idea. I look forward to that. Dino Otranto, thank you very much for joining us. You are back with the Energy Insiders podcast with Giles Parkinson and David Leach. And David, it's going to be interesting to see if Fortescue do get to real zero by 2030. I think if they get there or they get close, a bit like the renewables energy target, it'll be a game changer.
Well, I'm interested to think about how well they go with these new wind turbines that we've spoken a little bit before. I got quite interested in the logistics of wind, and I actually thought of writing something about it. But then I thought, as much as I'm interested, I'm not sure that everyone else really needs to know that the water's actually quite a lot of water's needed for the concrete and dust damping down, and that in fact you've got to transport all the heavy equipment. And in fact, the actual turbines and the blades, although they're the most difficult things to transport, probably only account for a small portion of the overall freight task. For traditional turbines, to sum it all up, you've basically got to move more or less 1 million tons of equipment for every megawatt. I think 1,000 megawatts takes 1 million tons. So that's a lot of millions of tons that we've got to move around the country over the next bit. So it's interesting to see if there are better ways to do it.
Absolutely. And with the self-lifting technology, you don't need these giant cranes brought on site. You can just get away with mobile cranes. So that's pretty interesting as well. And it's going to be interesting what they do with the electrification process for the electric trucks and how successful that is. The manufacturing of those is now going to China fully. So that's interesting as well. And about the electric train, the battery density, I thought was also interesting.
It's interesting about the gravity train. They've discovered, like most cyclists discovered, that even when the basic trip is downhill, that doesn't mean you won't do any uphill pedaling. Like I remember the first time I went in the Sydney to the Gong ride, I was shocked to find I spent seemingly most of the time cycling uphill. The downhill bits were fun, and it was a net downhill, but still tired when I got there.
Well, next time you go down the Wollongong Hill, maybe you should sort of carry some extra weights, and then that will give you more momentum to sort of get up on the other side. I don't know. You've got to remember to shed them at the bottom of the hill, though.
I think, there's some basic physics laws about gravity there that you and Galileo could discuss.
Yes, if he's around. David, the Queensland energy roadmap. God, bloody hell. Strike me pink. I actually drove my electric car all the way up to Brisbane to listen to that piece of nonsense. Just extraordinary, really. The chutzpah of the LNP government. They say they're open to business. Quite clearly on their own numbers, they are not open for business. All the numbers that they assume that will be built by 2030 are already in construction, in commissioning, contracted by Rio or underwritten by the CIS. It was interesting to see the reaction of the renewable energy industry at that meeting. I mean, some were really sort of pretty disgusted and pretty disappointed. Others were just going, well, look, it's not a credible plan. It's not a feasible plan. They're going to have to come back and build more wind and solar projects because those coal-fired power stations aren't going to last. They're going to need more wind and solar. More industry will be crying for it. So they will get built. So some of these people are still confident that their projects can move on.
Well, it's kind of funny that the actual modelling from whoever did the modelling, uses the ISP demand forecasts, which are all based around electrification, but they're assuming that their supply, there's not much electrification. Essentially, I mean, it's all the coal. My criticisms of it are many, but the two that stand out to me, and one that not every listener will agree with, is firstly, when the Queensland government owns most of the generation, you're terribly reliant on them making a good plan and good decisions. The Labor government for a long time did SFA. That's an acronym, Giles.
I won't spell it
like
out.
CIS, but with a different meaning. And then at the end, they did a great job with Mick de Brenny, but it didn't get all that far, as we know. And then a new government comes in with a different idea. So you don't really let in the private sector have its head and work out a more consistent plan and get on with things in its own way. So, I do have a criticism of unfettered government ownership of these assets. It doesn't always result in the best outcome, I don't believe. I absolutely believe that there are individuals and people out there in Australia with very good ideas, and if there'll be lots of ones with very bad ideas, but letting the market sort out what's good and what's bad is the one thing. That's on the one hand. The second thing is that when you focus so much on your base and ideology of running the coal stations for as long as possible, it doesn't really explain how you're going to grow Queensland and grow energy consumption and get new energy intensive industries, whether it's crypto mining or data centers or whatever it may be, to actually survive there, to come to Queensland, and you're still going to get all the negative consequences of climate change, the road damage, the floods, the droughts, the coral bleaching, and so on and so forth. You're going to get so. Look, it's what you expect from a conservative government. That's the definition. They're not liberal nationals. They're complete misnomers. They're conservatives. They want to conserve the existing way of life. But you can look more deeply into it, Giles, and some of us do. And we will see that coal mining, which is really much more important to Queensland than coal generation, is actually suffering as well. We've had retrenchments there in a couple of them, some of which will be described as cyclical, but the basic story is that Indonesia is stealing all the market share from thermal coal in Australia, not because Indonesian coal is any good. It's far, far worse than the Australian coal, but it's much, much cheaper as well. And there's lots of people that just want to buy cheap coal.
Speaking of coal, let's get on to Origin Energy. No real surprise. You've written a couple of analyses over the last few weeks and months pointing out that the market's not really factoring in a coal closure of Eraring in 2027. And basically Origin came out and admitted as such, saying it's a potential closure date, 2027. The hard date is 2029. And it talked about all the difficulties in building new renewables and the planning issues and the connection issues and all those things.
How would it know? It hasn't done any of that.
Exactly. I mean,
it's just like AGL. They're full of all the difficulties without actually having done any.
Well, they haven't tried or even done anything yet. Absolutely. I mean, it's got one wind project. I mean, remember, they actually flagged the early closure of Eraring in 2022. And then, to borrow an acronym from you, they've done SFA since then. And, they've advance the Yanco Delta, but they're not even going to make a final investment decision on that until late next year. So
Well, they can't. It hasn't got planning approval yet. It has to go back into planning. So and
there you go.
and it needs an upgrade to the Dino Wind substation to actually be built. So I think that's fair enough. And in New England, the transmission won't be there, but they could have commissioned some.
It's not fair enough because they haven't built anything since 2022. Now they're complaining, well, there's nothing there to replace the wiring. We've got to keep it open. I mean, it's holding the market to ransom.
Yes, but they will end up suffering for that in the long run. Like I think we should have mentioned before that how interesting it is that AGL is now moving to double shifting Bayswater power station. They need to do that. So what that means is they're actually closing it down right off and then warm starting it later in the evening. And that we're going to see more and more of that during the springtime. But you don't earn any revenue, obviously, when you're closed down. But the other thing that I've become aware of over the past year is that actually coal generators don't care about the middle of the day. It might look like they're losing money, but they don't lose much. What they really care about is that they're actually running when these price spikes take place, because that's when they make all their money. Like about 20% of the price that consumers pay in the wholesale price of energy comes from prices that pertain for less than 1% of the year. So you look at the screen, or I've said this a couple of times, you can look at the screen at this time of the year and 20 or 30% of the time the price is negative and you think, gee, that's really good. But that doesn't really make much difference. What makes a difference is that one of these days when Bayswater's closed and Araring's not working, it'll be a sudden cloud or the wind will stop and the price will go zooming straight up. And the guys that are around then will make a lot of money and consumers will have to pay for that.
And it's not just when the sun goes down behind the cloud and the wind stops. It's also anything that looks like a controllable market and the prices go up. I mean, it's not just a force of nature, David. It's bidding and rebidding strategies, something that the Australian Energy Regulator is more conscious of and making more sort of tutting sounds about, but doesn't seem to be able to change it.
Look, markets have a life of their own. It is a market. No, the governments don't control it. And it doesn't really hurt generators to have prices go up, even if they miss out this year, because it means that when the regulators get round to setting the price next year, it'll reflect what happened this year, and prices will be high again. Now, the only offsetting news about that is all the batteries that are coming on stream. There was a huge number of them already. I think I wrote in my notes something like about 16 gigawatts of batteries that are operating, commissioning and under construction. And then you can almost double that number from batteries that have been awarded a CIS contract. And whilst getting awarded a wind or even a solar CIS contract is like a participation certificate, doesn't actually mean you're going to do anything or win anything. So it seems to me. But the battery guys who've got one, they'll probably get on and build batteries because that's the market we're in.
Absolutely. And it's interesting to note that 12 of those, I think, as we mentioned last week, 12 out of the 20 that won the generation contracts have batteries with them. So they've probably got a better chance of moving forward. And we've seen that some others have options to add battery projects. And the next tender is already underway, 5 gigawatts.
Charles, the people I was talking to said they'd have been perfectly happy if these hybrid solar and battery projects had left the solar out.
Well, it's just performed. Victoria actually says it doesn't want any solar or solar battery projects in the next tender. It just wants wind. And I guess that probably reflects the difficulties it has of actually attracting wind. And it's lost another of the offshore wind projects. RWE's decided it's all too hard. Blaming costs and uncertainty over the auction date and withdrawn them. It doesn't mean that things aren't going to get built, because probably only 1 or 2 projects will get ahead anyway, and it might have decided that it wasn't going to be one of those.
Yes, Charles. Look, we shouldn't be too negative or too cynical. It's great to see these CIS awards, both for batteries, for wind and for solar. It's great to see the transmission getting built for better and for worse. And, the foundations are still being put in place that are around about somewhere between 2028 and 2030. There's going to be a bigger renewable. We're going to have a lot of renewable energy. Already, it's more than 50% in spring. We have crossed that threshold in spring now. We haven't crossed it and won't cross it for a full year. But in spring, consumers don't realise but they're getting more than half their energy is coming from renewable sources. I saw a survey today that said that lots of people don't want to buy electric cars at the moment because they're worried about range, they're worried about charges, they're worried about prices. But actually, the people that do have electric cars, if you did that survey, I think you'd find, at least speaking personally, we're all pretty happy with what we've got.
No, absolutely, yeah. There just seems to be so much negative stuff coming out about electric vehicles at the moment. It all seems to be a bit of an orchestrated campaign, as are the campaigns against renewables and what have you. I think the vested interests, the Toyotas and the other big car makers around the world, are sort of trying to push back because they can see things changing quite rapidly, particularly with the introduction of the Chinese car makers in Australia, which is one of the biggest and fastest transitions in terms of who dominates the space, because the Chinese car makers are more restricted in Europe and in America than they are in Australia. So interesting. Just back onto the share of renewables, 51.8% over the last 7 days, David. So there you go. You're
Yes.
quite right. I think that's probably a bit of a wrap for the day, isn't it?
It is, as far as I know. I haven't got anything else.
I've got nothing else. That's it. We've done our dash. Thank you very much to Dino Otranto from Fortescue for joining us.
But we'll be back again soon, Giles, won't we?
We'll be back again next week. I was coming to that. Thanks, of course, to our listeners and our sponsors, Evergen and Pylon. We will be back, as you just said, with another episode of the Energy Insiders podcast again next week. And that's bye for now.